Alright, hello everyone, this is Mr. Crozier. I want to give you help on the last two pages of the calculus packet. First one right here, we got to find the derivative here. Well, derivative of the first one's just the power rule, and then we have the derivative here, and if you remember, we leave the function alone, and then we add on the natural log of the base, so there's a 5 right there. So the first one, you just bring that down, then leave it alone, natural log of the base, and again, always a chain rule. It's always a chain rule. So the derivative of this value here, which is just 1. So you can simplify that. Number 48, the domain. Well, what numbers can you put in here? Well, you can put in here all real numbers. There are no exclusions on the domain. Critical points. What are critical points? Critical points are when f prime of x is equal to 0, when the derivative is 0. Increasing and decreasing intervals, well, increasing means it's going up, decreasing means it's going down, and you can put those on a table of critical points. And you always test the points in between, and you're testing this point here, let's call this point A, so you are doing f prime of A, and if it's going up, it's positive. If it's going down, it's negative. Relative extrema are the points themselves. This point here, let's say it's 5 and then f of 5, meaning you plug it back into the original equation. All right, down here, the limits. Well, the limit as x goes to 0 from the left side, so that means it's going up here and it's going up to 3. From the right side, well, it's going down to 2, negative 2. Well, what is the limit as it goes to 0? Well, if there's no symbol, that means you have to look at both sides, and these don't match, so it does not exist. Is there a value of 0? Well, sure. On day 0, I made $3. Number 50, type this in your calculator. You can type this in, and you get that output on the calculator. Let's see if I can show you that real quick. It is math. It means a numerical derivative, and you can type it in and put an x here. And the function 3 ln of x, and let x equal 4. So this is going to give you the value of this derivative at 4, and it's 0.750015. So really, I mean, you can kind of tell from this derivative is really 3/4, right? But since it's a numerical derivative, the calculator's calculating it, and it's an estimated, so we just type in everything. The key here is always make sure you put in the function, not the derivative. The calculator will do the derivative for you. 51's same thing as 49 here. The derivative here, well, what's the derivative of plain ln of x? Well, that's just 1 over x and the natural log of that base, which is just e, so that really just goes away. So a lot of times we just say the derivative here is just 1 over x. All right, so don't forget to do the chain rule there, and don't forget you're bringing down x in here, so you're bringing down 6x. And again, check it on Symbolab and you'll find out. The derivative here, well, it looks like a product rule, right? But with one step, I can change it into the power rule. So a lot easier. Do all your simplification first. Do this and then do the power rule. This is just a direct substitution. I believe if you directly substitute in 0, you're going to get a number. It's not going to be undefined. And the limit as x goes to infinity, that means on day infinity out here. Where's the graph? Well, on day infinity, all of this little stuff goes away, and the only thing that matters is this equation. So plug in infinity to here, and actually this can be simplified down further, right? On day infinity, this is all that matters. So plug in infinity there, and we have 4 over infinity cubed. Well, that would be 4 over something very, 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 very large. I think it's going to go to 0. But again, graph this on Desmos, and you will see the function, whether it goes down to 0 or up to 0, goes to 0. That's also called the horizontal asymptote, right? Y is equal to 0. It's going to 0. All right, on the next one, well, this is our related rates problem. Draw a good picture. It's a very common picture with a ladder posted up against a building. And there's a relationship there, right? And the relationship is x squared plus y squared is equal to 50 squared. And you could find the derivative in respect to time, which is speed, right? So you could take that derivative and you'd have some values, and you can just substitute some stuff in. And what do we see here? Well, the base is 30 feet away, so that's 30. I bet if you put a 30 here, you could do the Pythagorean theorem to figure out what y is. And they give you this rate up here. The base of the ladder is slipping away at a rate, so dx dt is 3. So when you take this derivative, you can plug in these values. I think here's one, and here's one, and you'll be able to solve for what you need. What are we looking for? Find the rate of change of the ladder. So we're looking for dy dt. And it's going to be negative, right? Because the ladder is going down, so it's going to be negative. Find the equation of the tangent. Well, we've done this numerous times, right? What is the equation? Well, take the derivative first of this, plug in, get your slope. Once you have your slope, it's y is equal to mx plus b. Find your slope through the derivative, and your point is something here. If you plug in 2 there, you'll get your point. And then you can put that in for x, that in for y. Find that. 58, just like those other graphs, think everything here we've done. Let's talk about this one right here. The limit as x goes to 0 from the left. So this way, where is that going? Well, it's going down to negative infinity. So most of the time we're going to say the limit does not exist here. It's going to negative infinity. That's not a limit. Either one's going to be acceptable. This is often like the behavior of the graph. That's a specific limit. Either of them will be acceptable, and there won't be those types of questions on the test to mess you up. Slope of the normal line. Well, that just means it's the opposite reciprocal, right? Because it's perpendicular here. So let's say we get a slope. This is just an example, but let's say we get a slope of 3 over 5. Well, we change it to negative 5 over 3. Or if we get a slope of 7, we change it to negative 1 over 7. So, and then we do the same steps here. The last one, a stone is dropped into a pond sends out a circular ripple. Well, we have the radius, so dr dt, the radius is increasing at 4 feet per second. We have a time here of 4 seconds. How rapidly is the area? Well, area is equal to pi r squared. And again, we're going to look for d dt because we want how far the area. So we're looking for what is dA dt. What is this? That answers the question. This one, it says after 12 seconds, how fast is the area increasing? Well, there's 2 factors here, time and the radius here. And the radius is what you're going to need in here. Well, at time 0, the radius is obviously 0, but after every 4 seconds, the radius is going up. So it's 4 and 8 and 12, and you can use that to find the radius that you need here. All right, well, I hope this helps with the problems. If you have any questions, email, and good luck on your final.